guys. Welcome to another Advanced Refrigeration Podcast E2 training. Today we're going to go over the subcooling application in the E2. This is not something that's widely used, but it's a great thing inside the controller. So you could actually do a electronic subcooler controller and or mechanical subcooler controller out of the E2. So let's get started. I'm doing this in offline programming today because I don't have a description file for it. This is something you had to pay for from Emerson. So they charge a charge for this, and you have to put a description file in. But on offline programming, it'll let us do all kinds of stuff that we don't have to pay for. So I already added the subcooler. I'm going to open this guy up, find the subcooler, edit the application. Okay, so device name, subcooler, long name, whatever you want to do with it. Okay, you have two different types. You have floating superheat, which means it'll float the superheat to control the actual liquid temp, or leaving liquid temp. So we're going to control off leaving liquid temp. Okay, leaving liquid temp set point, 50. Okay, control enable set point is when it is enabled from the outside air temp or liquid temp or whatever. So we'll go 55. And then you got a 5-degree deadband. EXV fail percentage. So on here you have what you want the EEV to fail at. Say if a sensor goes bad or something like that, you always want it to be 0. You don't want it to fail on because you could potentially be flooding out. So make sure that's at 0. Minimum superheat set point, 8 to 10 degrees. Flood safe, fail safe set point, I would go 5 degrees. You could play with this. So then you're going to pick your refrigerant. So we'll say 507. So valve sync, that is at midnight. It's going to sync the valve every day. Update rate, I recommend changing this to 2 seconds. Okay. Now this is your basic stuff. Now to your inputs. So you're going to need suction pressure, suction temperature, leaving liquid, entering liquid, and an enable. So I recommend you tie the enable into the suction group subcooler. So if you go down here, you choose enhanced suction. And you find subcooler. So this is from the suction group. So if there's a failure in there, it'll kill the subcooler. So if there's too many compressors off on oil, if the suction pressure is high, if there's some kind of shutdown, high head scenario, it'll kill that. So your suction pressure, obviously you're gonna need a transducer in this scenario. You're gonna need a transducer put on the subcooler. You're going to need a suction line temperature sensor on the subcooler. You're going to need a leaving temp and entering temp. You do not need the entering temp. A lot of times I end up using a droplet temp as the entering temp just to save the sensor. So I'll assign the droplet temperature as the entering temp and make that my enable. And then I'll use my leaving liquid temp. I'll put a sensor there. So then under outputs, okay, so an alarm is going to be, that is an alarm set point. So EXV percentage. Now you're going to tie this to a multiplex ESR board. So you choose in here, find the multiplex ESR. Somewhere in here. Oh, there it is. Valve, say valve 2 percentage. Okay. Okay, then you have your status right there is on. Current superheat. So this is just a readable point. So I usually make a sensor control, a couple of them, and I'll assign it for a current superheat. Approach temp same thing. I'll assign the approach temp. Now, saturated suction temp, I'm not really concerned with. I mean, you can come in here and read this. EXV fail percentage, not really concerned, and overclose, not really concerned. So this overclose percentage, you want to EXV fail percentage. You could tie that to the ESR also. There it goes. But yeah, current superheat you want to log, all this stuff, EXV percentage you want to log. Status, I recommend you set the logging up for that. Okay. Then alarms. Okay. Now you have all these alarms. High leaving liquid temp. Obviously, I would probably do an alarm. So I mean, some coolers get missed all the time for not having alarms. So I would do like 65 degrees, and do like a notice at like 60, and do it for like 15 or 20 minutes. If your liquid temp is 65 degrees for say 30 minutes and your subcooler is not working for that long, there's obviously something wrong. Low on gas, I mean subcooler issues. I'd rather catch it now than have 5 techs go there and adjust valves because the subcooler is not working. So, I mean, having an alarm in a subcooler is a great idea. So you can adjust the priority on there, um, for the notice and the alarm. So now you have a low leaving liquid temperature. I'm not really concerned with that. I mean, I really don't care. High superheat alarm set point. I mean, I'm not really caring about high superheat alarms, but low superheat alarms I do care about. So I'll usually make them notices. If it's at 0 degrees, yeah, for like 5 minutes, it should probably alarm. So you have all your alarm set points in here, guys. So you can sit here and go through and set all these. I mean, there should be alarms. I mean, just make sure they're not too tight. So then we have our PID on here. So we do not have an I gain or a P gain here. They're using the TR range for it. So they're using the TR range for your P gain, and then your I gain is right here. So what my recommendations for you guys is when you're setting these up and tuning them, I take the I gain down to 0, and I start with a TR of like 5, and I slowly start to raise the TR until the loop stops, hunting is bad. So what you want is think of the TR like your P loop. So you want to get that to head just where you have sawtooth. So it's just under and over a little bit. Like it's not like hunting up and down like 5 degrees. You want it under and over a little bit. Okay. Once you get to that point and you're stable and you get the P value to where you're like a degree under and over set point, then you start introducing the I value. Do like 0.5 or 0.10 at a time. And what this will do is the I value will add to the equation or subtract to the equation over time, and it'll cut up the sawtooth and make it more of a straight line. Because the TR value is trying to eliminate the set point error. So it is trying to eliminate the set point error in the superheat. So it is trying to either add or subtract to the output in order to bring it back down to set point. Okay. The I value is going to add or subtract to bring it down to set point over time. So the longer the loop runs, the more I it's going to add or subtract. This is why that update rate I took from 10 seconds down to 2 seconds, because now you're going to be looking at the loop every 2 seconds. 10 seconds is really long for a PID, or a PI loop. We aren't running PID loops. Like, majority of what you're going to do in refrigeration is just going to be PI loops. I mean, we don't need D. We don't need it to be, thinking over time that much. So we just need short changes over time where the I comes in. But you're going to have to tune these. Do not run the stock settings. You're going to flood out or you're going to have very poor control. But make sure that EPR is set up. If you have a manual EPR, which you should, I don't recommend using a stepper unless you're just controlling off pressure. So if you're using a manual EPR, make sure it's set higher when you're trying to tune this PID. So there is no, the compressors aren't affecting it, nothing else. You just have a solid suction pressure and you have a steady variable. So if you have the variables, like if you have two different variables, say suction pressure and suction temperature jumping all over the place and fighting each other, you're never going to be able to tune the loop. You need steady suction pressure so that way the temperature is the only thing varying. So once the temperature, is varying, you could tune that in. So just remember that, guys. Just make sure that if the suction pressure is jumping around, you're never going to be able to get this thing tuned in. You need steady suction pressure so that way you could tune the loop. So again, so make sure when you're tuning your PID loops that everything is steady. Give it like a 10, 15 minutes of runtime in between making adjustments. Don't make any adjustments when stuff's in defrost. And same thing, you should do this under a decent load, like 90-degree liquid. If you got to crank up your head pressure, then do so. So that's what I recommend you guys doing if you're going to tune these PID loops. But just remember, go slow, little changes. Little changes make big changes. So again, here's the description file revision. That's something Emerson will have to give you. So when you pay for a description file from Emerson, they will cut you a PO for a description file and for that controller, and then you'll have the subcooler application. So this takes over having to have a like a Sporlan subcooling controller, Dixel. I mean, this is a standalone subcooling controller on E2. It's a little bit nicer because you have the graphing capabilities. It's all on the E2. You can use a multi-flex ESR board, so you don't have to have a standalone device for whatever it costs. I think it's like $50 or $100 for the license, which it's another $50 or $100, but you're not buying a third-party device in order to run this. So I mean, it is nicer. So this is an option in the E2. It's not one you see a whole lot, but it's a great option because everything's still in here, and you can adjust everything on the E2. So this is one way to do it. You could also do a Sporlan subcooling controller. You could also communicate with that. You could drop it in here, and I don't have the revision file on this E2 for it to be able to do it. But you could also communicate with the Sporlan subcooling controller and grab all this data, and also do that way. It's the same setup. You just got to go through and set up the Sporlan subcooling controller inside the E2. It works just as good. I mean, this is a little simpler just because Emerson has basically dumbed it down to the point where you only have to input the settings you need, and you don't have hundreds of settings like the Sporlan subcool controller inside the E2. Because every set point that you could change in the Sporlan subcool controller, you could also change in E2, which makes it kind of difficult at times. But all right, guys, that's how you set up the internal subcooler on the E2. Thanks for watching.